Okay, so this is the second video. So in this one, I'm going to be looking at the docs. So I'll start from the docs project. Hold on. So 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 this would be the project that would have the documentation. So I'm sure I can read it without the without too much so let's see what we have here. We have the resources, let's ls the resources, ls resources ca uhn Hapi-fhir docs. Okay, and then we have all the files here. Yeah, so let's cd to resources main Hapi-fhir main docs. Why is it okay, control K. cd resources ca Hapi-fhir okay. And then so these files are in Markdown, so I can pretty much just go through and read some of this. Let's see. Okay, so cd into getting started, and then ls downloading and importing. If you're developing applications in Java, the easiest way to use Hapi-fhir is to use a build system which handles dependency management automatically. The two most common systems are Maven and Gradle. These systems will automatically download dependency libraries and add them to your class path. If you're not using one of these systems, you can still manually download the latest release of Hapi by looking in the release. Try looking in the release. To use Hapi in your application, at a minimum, you need to include the Hapi-fhir core jar, as well as at least one structures jar. The structures jar contains classes with the resource and data type definitions for a given version of FHIR. If you're using Maven, the following example shows dependencies being added, including DSTU2 and R4 structures. So DSTU2 and R4. Note that if you wish to perform validation, you may want to include the validation resources jar, which contains schemas, profiles, and other artifacts used by the validator for your given version. Gradle users, if you're using Gradle, you may use the following dependencies. Note that if you're doing Android development, you may want to use our Android build instead. This is the snapshot builds. The Hapi-fhir project generally releases a full software release 4 times per year, or approximately every 3 months. Generally speaking, it is a good idea to use a stable build. However, FHIR is a fast-moving specification, and there's a lot of ongoing work in Hapi as well. There may be times when you want to try out the latest unreleased version, either to test a new feature or to get a bug fix. You can usually look at the change log to get a sense of what has changed in the next unreleased version. Snapshot builds of Hapi are pre-release builds which can contain fixes and new features not yet released in a formal release. To use snapshot builds of Hapi, you may need to add a reference to the OSS snapshot repository to your project build file. Using a snapshot build generally involves appending snapshot to the version number, e.g. 410 snapshot. In order to automatically download snapshot builds, you may also need to add a snapshot repository to your build file as shown below using Maven. Using Gradle. Dependencies. The Hapi-fhir library depends on other libraries to provide specific functionality. Some of these libraries are listed here: logging, S4J, SLF4J, logback, etc. Hapi-fhir requires SLF4J for logging support and is recommended to include an underlying logging framework such as logback. Stacks, Woodstock. XML processing for resource marshalling and unmarshalling uses the Java Stacks API, which is a fast and efficient API for XML processing. Hapi bundles for release archives and depends on the Woodstock library, which is a good implementation of Stacks. Upon starting up, Hapi will emit a log line indicating which Stacks implementation is being used. For example, XML processing using Stacks implementation, Woodstock XML processor version. Although most testing is done using the Woodstock implementation of Stacks, it is not required, and Hapi should work correctly with any compliant implementation of Stacks. You can force Woodstocks into an environment where multiple Stacks libraries are present by setting the following system properties. System set property. For example, ph schematron. If you're using the schematron validation module, you also need to include the ph schematron library on your class path. Note that prior to Hapi-fhir 3.4.0 we used ph log schematron instead, but that library has been discontinued. If you're using Maven, this library is not added by default. It is marked as an optional dependency, so not all applications need schematron support. As a result, you need to manually add the following dependencies to your project POM.xml. So there we go. So downloading and importing, and then introduction is an implementation of the HL7 FHIR specification for Java. Explaining what FHIR is beyond the scope of this documentation. So if you have not previously worked with FHIR, the specification is a good place to start. This is often not actually the case when discussing message protocols, but in this case it is so. The FHIR specification is designed to be readable, implementable, and is filled with good information. Part of the key to why FHIR is a good specification is the fact that its design is based on the design of other successful APIs. In particular, the FHIR designers often reference the HiRise API as a key influence in the design of the specification. Hapi-fhir is based on the same principle, but applied to the Java implementation. We've based the design of this API on the JAX-B and JAX-WS APIs, which we consider to be well thought out and very useful. This does not mean that Hapi-fhir actually uses these two APIs or that Hapi-fhir is compliant with JAX-B, only that we have tried to emulate the easier to use, a flexible design. Add it to your project. See downloading and importing for instructions. Before discussing Hapi itself, a quick word about FHIR is not yet a finalized 1.0 standard. It is currently in the DSTU phase, which means it is changing in subtle and not subtle ways. Before trying to use FHIR, you will need to determine which version of FHIR you want to support in your application. This would be the latest version, but if you are looking to interact with an application which already exists, you will probably want to implement the same version implemented by that application. Hapi defines model classes for every resource type and data type defined by the FHIR specification. For example, here's the patient resource specification. If you browse the Java doc, you will see getters and setters for the various properties that make up a patient resource. We'll come back to how to interact with these objects in a moment, but first we need to create a FHIR context. FHIR context is the starting point of using Hapi and acts as a factory for most other parts of the API, as well as a runtime cache of information that Hapi needs to operate. Users of the JAX-B API may find this class to be similar in purpose to the JAX-B context class from that API. Creating a FHIR context is as simple as instantiating one. A FHIR context instance is specific to a given version of the FHIR specification, so it is recommended that you use one of the factory methods indicating the FHIR version you wish to support in your application, as shown in the following snippet. The parser instance can then be used to parse messages. Note that you may use the context to create as many parsers as you want. The FHIR context is an expensive object to create, so you should try to create it once and keep it around during the life of your application. Parsers, on the other hand, are very lightweight and do not need to be reused. Java. Encoding a resource to it. The parser can also be used to encode a resource, which you can populate with your own values just as easily. This section below on fluent references the snippet above, so be careful about any reordering. This code gives the following output. So in XML, this would be a patient with a hospital, an identifier of some sort, and then a name. Much of the Hapi-fhir is designed using a fluent style where methods code can be changed in the natural world. This leads to tighter and easier to read code. Is functionally above, identical to the example above. JSON parsing and encoding is also supported. This code gives the following output: resource patient identifier. So this is this. All right. So I've already done downloading and importing in the documentation, and introduction. So last one I'm gonna do for now is the R4B. The FHIR R4B is an unusual FHIR release meant to help certain users take advantage of certain FHIR R5 models and features before the release and adoption of FHIR R5. Functionally, R4B is mainly identical to R4 but with specific resources backported from R5. As of Hapi-fhir 6.2.0, this version is now supported. For a complete table of FHIR specification version supporting Hapi-fhir software versions. Support for FHIR R4B is experimental and may never be completely implemented. It has not been extensively tested, and we're not currently aiming for feature parity with normal future FHIR versions support. Well tested and should be functionally fully functional. Is well tested and should be fully functional. Is well tested and should be, as there is no need for any in this part of the validator does not currently work with R4B and may crash or cause unexpected result. Note that the underlying instance validator is able to validate R4B resources, so this should be fixed in the future unless if demand is there. The FHIR validator site can also be used. Is able to store data, supports all basic storage interactions. Search also works, including built-in and custom search. Tested, including subscriptions, terminology, service, etc. All right. Yeah, I'm gonna stop